Ah, there it is. Okay, right. Let's start off. If you read my bio, I said I'm a server jockey in a network world. And that is me. So, quick outline. Is this one on? Right. I hate to be a moving target, or I love to be a moving target. It prevents people from hitting me so quickly. So, quick outline, intro, why we use virtualized firewalling, brief history, virtualized firewalls, how I've done it, where to next, and future endeavors. I hope everybody got their VPP listeners on, because we need to rush through them. Okay, there's a list of reasons why you want to use virtualized firewalls, virtualized networking, and go through them. But the one thing to remember here, you have a Swiss Army knife available. Not a specialized tool for specific use cases. It's a nice tool. You can do lots of things with it. It's a tool in your toolbox. There's a brief history of the Linux networking, and this is the progress that I had to go through. First, we had dial-up networking. We had to enable IP forwarding in the Linux. We had our first firewalls on Linux, abundant IPs at that stage. I cut my teeth on Checkpoint's Firewall 1 and the Sunscreen SPF from Sun. Nobody have heard of that one, I believe so. And then in 2000, we got this prophecy of shortage of IPv4s. No more 10 by T, 10 by 2. Who in this room ever worked on 10 by 2? Yes, we do remember those days of terminators and the loss of termination. And then we started to get IP change. We have the, which one is the, but yeah, so we started with stateful IP change, which was stateless. Then the IP tables, that was stateful. We will have funds with DNAT in and out of Linux. In 2.2, we got the bridge included. And this allowed me to do fun things with a laptop. You have the laptop, 2 Ethernet adapters in it. Well, you have the onboard one and the PC MCIA Ethernet adapter. And you could use that as a packet sniffer out at the client side. Interesting things that I've had to do to fix things on that. But also, we had the first EB tables for firewalling on a bridge. VLANs got introduced, various different standards. The initial things like, apologies, which is the laser pointer? Ah, there it is. Okay, we recall Ether trunking on Cisco, or Ether channel on Cisco, and ISL on Cisco. All of those things had different names for different things. It basically means it's a VLAN on the Ethernet segment that you were running. Eventually, we got 1Q standardization that everybody today would be using if they are talking VLANs over a network. The funs in Linux was we had different types of VLAN names for them. Then in around 2000s, we got the universal TAN-TAP driver. And the reason why I mentioned this is the thing that provides us, what is it, VPN connectivity, and typically used in VLAN or VPN software, but this is the building block, if you don't know about it, for virtualization bridging in a Linux environment. Also, there was the Zebra thing that got turned into Quagga, and today is FRR routing. Various routing options available, and the one thing that started to have fun for me was VPN concentrators. Name of a network function, and we can do it now. That was the fun part in the Linux environments in those days, or even today. The biggest limitations that we had is port density. Best was a dual 100 megabits per second Ethernet. Yes, there was quad bus interface, quad Ethernet options on the Sun S-Bus. We were still stuck with single core CPUs, and I/O typically had to go through a south bridge to get to the CPU. Everybody remember that, funds? Then we started the virtualization. That was the first one I actually had fun with, was the VMware desktop. When started to come out, Zen was the first one on the Linux environment that was a thing. Never had the time to cut my teeth on that, but there's also Beehive from FreeBSD. I'm going to use the term guests from now on for anything that is a VM or a virtual or a container. They are basically doing the same thing, it's just how you do the TAN-TAP interfacing on the host for the guest. One of the things to always remember, all guests need networking of some sort. Show me a VM that does not have a need for a network interface, it's basically mostly a useless thing. You need networking because that is what we need to talk to everybody else on the network, or to make it useful for somebody. The one question that remains in the virtualization is where and how to connect the network endpoints. Typically, it's either a bridge setup with a LAN interface or a bridge setup with a NAT gateway. In other words, your VM doesn't connect to the network locally, or does it connect to the local network on the Ethernet? Does it appear to be a host, a desktop on your local network or not? Or is it hidden behind the host IP address? And if you look at this one, it's basically an IP tables firewall that's happening in your guest. So the first time that I got introduced to the idea of having a whole network inside your PC was doing a COSA DNS course where the presenter was creating a whole network of DNS servers, each for the students, separate network, separate IP addresses, and that sort of started to pique my interest. How to do this? What's the funds on it? And so we come to how to virtualize firewalls eventually. So a point to make at this is that my typical clients that I have the need for a firewall, fronting their jump host, fronting their application web server with the database behind it. Everything then connects to the internet through the firewall. It's not the usual case that I have clients that have their devices, their VMs straight on the internet connecting. So, a basic setup for this is that each network is a bridge interface. That was the COSA thing. Each student connects to each relevant bridge. There's a router that connects all these bridges, and it needs to some DHCP firewalling. What made things fun lately, that was on a single machine, yes, multiple cores, but you need to have enough RAM to handle the guests. It just speaks of common sense on that one. So, introduction to ProxMox. I got introduced to that in about 2012, 2013, and this is the part where I started to say, well, here is something that is useful that I can use and start doing guests. Simple, easy, it has a nice interface. But the first steps was all guests connect to the same bridge, and that same bridge connects to your local LAN. Everything appears to be as it's on the local LAN. You don't have a host or a firewall between those PCs or those guests and your network. And eventually, I had to upgrade my firewall at home, which was a Linux machine with an Ethernet for the WAN, Ethernet for the local LAN, and starting to get this onto ProxMox. And this is sort of the environment that you have. I see there's a little bit of coloring that got missed. But the basic idea is everything here sits in a PC. At home, you have Ethernet 0 that connects via a actually a TAP interface to your, one VM, a bridge. That bridge connects to a firewall VM. That firewall VM then has connectivity to all your different devices or VMs inside it, and segregate on those devices or guests. So the other part is that one, that VMBR, that typically also has an Ethernet interface, going to the local LAN, and that we have devices on that one there. Then I got introduced to VLANs. What is it? 1Q VLANs, and the first one that makes that nice was the Open Switch. Open Switch is the first one that, or the first bridge set up in Linux that had VLANs available. The Linux bridge with VLANs only came later. So the VLAN bridge one had some challenges on that one before. Okay, so this is then what I then start doing with Open Switch. You have your bridge with a trunk interface that then have your different VLANs, and the VLAN for the WAN as well as the VLAN 1 going to your local network there. And that is how you then use that virtual machine with a trunk interface to the bridge, and the bridge then have the different VLAN interfaces. Caveats and enters on this one. You have your, everything goes through the one Ethernet to the WAN, and you have the trunking interface. The fun then starts when we get clusters. Clusters, we now have this case, that this firewall, we don't want to duplicate it across the cluster, but in most of the hypervised, or is it the hosted environments, we have an Ethernet interface going to the WAN of each of those hosts. But then they have a shared Q&Q network at the back, you have that VM there, and you can then match it across. The challenge with this one is VLAN 666 there and VLAN 666 there going over this bridge, you now have a problem going from that firewall. The solution to that one was to split up the node 1 Ethernet to a VLAN 667, node 2 go to VLAN 668, all in the same. The firewall just have two IPs, one on VLAN 667 and one on VLAN 668. That then gets split. So what you now have a case that VLAN 667 from the firewall gets an IP there, exit on that interface, whereas 668 exit on this one through this trunk interface. So now you have two IPs on the firewall, still having all of these interfaces, devices, going through that trunk interface, go outside there. The biggest problem that I hit with this one was a provider that had a big provider. The fun with them was they had, compared to this case, come on, this case, this switch here, the Q&Q versus the WAN interface were all separate switching infrastructure. So it was nice, it was easy to do. The problem with the second provider, that hit me was both this switch here and the switch on that side was the same switching infrastructure. So I had a fun challenge that when the packet going for VLAN 668 enter the VLAN on this side, or the WAN on this side, on this switch on this side, enter the MAC address, going to the firewall over here to there, this switch, which is the same one here as there, notice the same destination MAC going to two different interfaces. And because of that, it basically locks the ports and say, well, I have a bridge somewhere. Talking to the network administrators, the challenge was that the Q&Q, the MAC address, was in the front and not after the VLAN. So because of that, even though it's different VLANs, I enter it there on the native VLAN, exit here on VLAN 667, the MAC addresses were still seen as the same on both sides. They did not like that. So this failed for me in that environment. They, however, had a VRAC solution, which is a little bit different. Everything then goes into the same network, where I can then have a native solution. Oh, not a native solution, native solution. So what happened there was then, instead of having a network on that side, Everything sits on this side. And the difference here is the native one is the outside to the WAN, to the internet. Everything else then was still in the Q&Q. So what happened is native VLAN comes in. It gets trunk native to VLAN 666. It's the firewall. The firewall then have all the other VLANs on it, which it can then over the trunk interface connect. And we still have ability to have this firewall migrate to anywhere else, and it will just continue working in this environment. So I'm busy moving from that big provider local, and the solution was doing it local, a cheap provider with LACP as a bond as before. That did work. The challenges was we had some L2 fun. The biggest fun on that was you have the packet entering switch A from port A on the bonded interface of the server, going into switch A. Switch A over the MCLAG sends it to switch B, which then goes to the B port on the second server. The challenge was that in that, the second server returns on port A or to switch A, and then it goes to the server. But when you have a second or a third switch connected to that on a different DC over that same VLANs, the traffic goes to the other DC instead of staying local because of the way how the switching goes into switch A, to switch B, to server 2, and then goes from server 2 to the A interface to switch A. So a second switch never sees the return traffic, so the destination never gets entered into its MAC tables, and you have some strange broadcasts happening on that. And that brings me to where to next. I don't want to use OEM hardware switches. I want to use, yes, I could use Linux bridges, but then I'm still with L2 troubles that I'm stuck. But I've been moving towards VXLAN with FRR, where the first step is you basically set up an L2 between your servers. You throw away all your switches. You have a meshed setup where I then have loopback interface routing, and on top of that IGP, I put my VXLAN. Lots of loopback interfaces. Bridges then connect to a VXLAN VNI. So that VNI then becomes the part that gets the L2 is then run over the L3 between the nodes. There is some challenges with that with regards to Open vSwitch. You do want to stuck with the Linux bridge at this point in time. But yes, what is my future endeavors on this? The future endeavor is to use cheap hardware with VPP. And the fun part of that is suddenly you have a 2U quad node with 2 half-height PCIe 3 interfaces. I have like 4 times 4 with another 2 times 4 plus 2 half-heights. I suddenly have quite a number of ports in 2U that I can have 4 routers on, doing things like connecting to my peering points, connecting to my IPT, as well as connection to the bottom side of my network. So what's the conclusion? The conclusion with this one is we can throw out all our OEM routers and switches by going open source solution. We can do a switch network between hosts to start. You can go a mesh network with L2 redundancies. Yes, FRR then runs on each node. Each node becomes a router itself. And on top of that, VXLAN, which we can put redundant VLANs across hypervisor server nodes. And my next step will be to put them across DCs. My only switch in my current setup is the one for the out-of-band, the Ethernet RJ45 switch. For a single hosting rack setup, you could do remote set, redundant upstream and peering connections all inside your ProxMox server stack. In a 2U space with 4 routers, 8 to 12 ports per router node. It's an exercise for the user how efficient that is. Yes, VPP is next on my list. Just haven't done that, and that leaves us for Q&A. Sorry if this was a fast run. I was hoping for a 40-minute time. Any questions?
Hello, Ed from, I guess, Edge Connect this time around. We run quite a large ProxMox install. We've been sort of like slowly looking at doing the VXLAN stuff that seems to be built in with ProxMox. Why are you not using that rather than doing a separate install out of interest?
So yes, I am doing that in my current setup. I have not documented that. We will need another 20 minutes slide, sessions that I have to compress 40 minutes in. So yes, the current setup, I do use that. I can tell you the problems that I have with that is currently, actually as of today, I saw the Bugzilla report from from ProxMox. The up-down, the IF up-down 2 does not support the VXLAN endpoints over IPv6 yet. The kernel does. They only do it in IPv4. So in my current stack, yes, I do use that, but I found there is still a few things that you want to do manually. So I do that. My rack is VXLAN or a VM, a 1 queue on top of a VXLAN, on top of a meshed Open Fabric network. The fun is why I used Open Fabric. There's issues on that. We can talk about that in a different one. But it's Open Fabric, but I had to manually configure the underlay part of that. Yes, you can do it with ice. I've actually set it up on another stack with that. That stack was decomped for reasons. But it's possible, it is doable, it is usable, yes. I found in my cases, I had to manually tweak a few things.
Cool.
Hi, Warwick from Network Platforms. Can you share some real-world stats on throughputs and packets per second that you're seeing and what CPUs you're using?
I have not done those tests yet. I have a preference towards, my compute cluster is single socket AMDs. I have affinity for anything dual socket for all of the dual socket reasons. No, I can't give you stats because I've never really benchmarked that yet. I don't expect it to be that low or that high, but the challenges was for me is that I've not tweaked it for it because my client did not have the needs for it. But I can say that I do 1 gig of database synchronizations on a quite frequent scale on the 4-node mesh setup with VXLAN on top of Open Fabric.